So there's an intersection feature on your calculator, but this does have some limitations. So first, each equation must be solved for y. Now we learned in the last unit how to solve an equation that was written with many variables, how to solve that equation for one in particular. So an equation to be solved for y means we need it in the form y equals, and on the other side we need an expression with no y in it. And then the calculator can only find the intersection point if that point is visible in the viewing window. So sometimes it means we need to play with the window options, x min and x max, on the calculator to find that intersection point. And then the calculator can only find an approximate solution. So you do need to verify that what you think is the solution really is. So example 5 says to solve the system from example 4 using this intersection feature of the calculator. So the first thing that we need to do is we need to solve for y in each equation. And so here's y in our first equation, and here's y in our second equation. So on the current side that y is on in our first equation, it already has a positive coefficient. So to get y over here by itself, we're going to, again, remember there's a plus 2x. This is assumed to be positive if there's no sign given. So to move this term, we're going to subtract 2x from both sides. So we're going to start with 2x plus y equals 2. And we're going to subtract 2x from both sides. And that will give us y equals 2 minus 2x. So this equation is solved for y. We have y equals, and on the other side this expression has no y in it. Now if we take our second equation, negative 2x plus y equals 6, and again we're trying to solve for y, so to undo the subtract 2x we're going to add 2x to both sides, and that will give us y equals 6 plus 2x. Okay, so again this is now solved for y. We have y equals, and this expression on the other side has no y in it. So now in your calculator you can push y equals and kind of scroll up and down in that screen from y1 all the way down through y0 and clear out any equations or symbols that may be in there. Okay. And then we're going to enter these two equations. So next to y1 we're going to put our first equation. So y equals 2 subtract 2. And then to type the x, you have a button on your calculator that looks like this. Okay, so if you push that button, it will type an x for you. Okay, and then next to y2, we're going to put in our second equation. So 6 plus 2, and then again to type an x, you're going to push the button on your calculator that looks like this. Okay, so on the screen, we've got our two equations entered. All right, so now to graph those equations. We're going to start by pushing zoom 6. And this is the standard window that sets our window back so the x-axis runs from negative 10 to 10 and the y-axis runs from negative 10 to 10. Okay. And we're always going to start with the standard window, and then from there we may need to adjust the window to be able to find the intersection point. Okay, in this case we can see that our two equations, we can see our intersection point right here. Okay, so is the intersection visible on this particular screen that we started with? And the answer to that is yes. Okay, so if so, we can then ask the calculator to find where that intersection point is approximately. So second, and then trace, and in that menu next to button 5 it says intersection. The calculator that will then ask you a series of 3 questions about which is the first curve, the second curve, and a guess. Currently we only have the graphs of 2 equations on screen, and we don't really need to give it a guess for these simple linear functions. So you can just hit enter, enter, enter to get by all 3 of those questions. And after doing so, you should see on the bottom of your screen where it says intersection, x equals negative 1, y equals 4. Okay, so that means this point, its coordinates are negative 1, 4. So again, keep in mind that the calculator will give us an approximate solution that is sometimes the exact solution, but sometimes it's just really close to what the real solution is. So we do need to verify that this point actually does satisfy both equations in our system. So again, if we start with our first equation and remembering to put parentheses around each variable before we substitute. And then we're going to replace x with -1 and replace y with 4. So we're going to get -2 plus 4 equals 2. 2 equals 2. So that's true. So we do know that that point -1, 4 makes our first equation true. Okay, so now let's check our second equation. -2. Again, we're going to put parentheses around each variable before we substitute. So now we're going to put -2, and we're going to plug in -1 for x and 4 for y. So -2 times -1, we're going to get a +2 plus 4 equals 6. 6 equals 6, which is also true. So since this point -1, 4 is the only point that makes both equations true, this point -1, 4 is the solution to the system of equations.